Okay, so for question number 1, okay, we've got to calculate, first off, the total distance traveled, and remembering that this is a position versus time graph and not a velocity versus time graph. Okay, so doesn't go very far in this first section because the line is flat, okay, which means it's not moving, right? It's staying at position 0. Then it descends, okay, down to 3. Then it goes from -3 to +2, which is another 5, okay? So basically, if they've got the numbers written, okay, for all the parts of this graph, okay, where this one was 3 and this one was 5, and this one went from 2 to -6, which is 8, and then this one went from 6 to -2, which is 4, and then another 2, okay? They added them up, so they have that written or they have a diagram somewhere. That's 4 of the marks. It's pretty generous 4 marks, but that's what it is. Okay. Then when you add them up, you should get that the distance traveled is 22 meters. There should not be a positive on that number, okay, because distance is scalar. All right. They must have the units though. If they don't have the units, then it's wrong. They won't get the answer mark. Okay. All right, and then the second part, what's the average velocity for the whole trip? 0. Okay, average velocity for the whole trip is 0. If they showed v equals d over t, 0 over 20. 0. I was feeling really generous for some reason today. I don't know. Okay, so that one's out of 8 marks in total. Okay. Questions on number 1? All right, question number 2, using the graph at right, calculate the total displacement of the object. Well, this is a velocity versus time graph. So I need to take average velocity and multiply it by time. Well, for the first part, that's easy. The average velocity is 4, and the total time is 2. So base times height, right, gives me that I have 8 there, and then I have a triangle that's basically half of that. Okay, so its height is 4, its base is 2. Right, so we're looking at 4 there. All right, so if they showed either that or they showed the area calculations here, they can have 2 marks for that, and adding them up for positive 12 meters would be their 3rd mark. Okay, so that one's out of 3. If they don't have the positive on it, it's wrong. It is a vector quantity. Okay, any other questions on that one? All right, it's out of 11. Please give them a mark out of 11. Let them see it. Put it in the box. Okay, so in this question we roll a ball up a hill. Okay, so as soon as I'm done rolling it, what's the only force acting on it? Gravity. Which way is gravity pulling it? Back down the hill. Okay, so that's the key part of this, is that it starts up the hill. Okay, and I'm going to make up the hill positive here. Okay, so it's moving up the hill at 4.5 meters per second, but it's accelerating down the hill at 2.1. So 2.1 needs to be negative. Right? And the time is 3.5 seconds. Okay? We're looking for final velocity. Okay? It's important that this is negative because it implies that it's slowing down now. Okay? And in fact, by the end of this question, it might actually be moving backwards. Right? If I roll it up the hill, it doesn't keep going up the hill. It eventually stops and comes back down. Okay? And that's what's going to happen here. If I don't make this negative, then it says the ball is doing what? Defying gravity and accelerating up the hill all on its own. Okay? Which it's not doing. Okay? All right. So we've got A equals VF minus VI over T, and we're solving for VF. Okay? So we multiply both sides by T. And then we add VI to both sides. All right, and we've got VF. Ringing a bell from yesterday? Okay. So we've got positive 4.5 plus 3.5 times negative 2.1. Okay, that's our time, that's our acceleration, that's our initial velocity. All right, so 4.5 plus 3.5 times negative 2.1. All right, so my final velocity is that the ball is moving at 2.85 meters per second down the hill. Okay, and that's the key. That's another thing that I wanted to illustrate with this question is, yes, the calculator spit out negative 2.85 meters per second. The question did not give me positive and negative as vectors. It gave me up the hill and down the hill, which I know this really seems anal, but that's different than up and down. Up and down is vertical. Up the hill and down the hill is angled. Yeah, you know what? They actually had a multiple choice question a number of years ago on the physics diploma exam that was like this. And the options were this number up, this number down, same numbers up the hill, same number down the hill. One's right, one's wrong. Okay? If it's that number, the number's right. But if you say up and it's actually up the hill, your vector's wrong. Yeah, it's that anal. Sorry about that. That's the way it goes. Okay, so our final answer then would be 2.85 meters per second downhill. Okay, I probably wouldn't be that sticky. Okay, if you wrote down, I would accept that. But if you wrote negative, I wouldn't. Okay, that's not the vectors the question gave. All right, so your vectors in your final answer always need to match the vectors given in the question. Okay. All right, questions on how that one worked? Do we need to move it up? Yeah. All right. First question on your worksheet there has something that we talked about yesterday. It gives you the speed in kilometers per hour, but then it gives you everything else in meters per second squared and seconds. So what do we have to do with the kilometers per hour? Divide by 3.6. We got to do that compound conversion. You multiply by 1,000 to convert it to meters. You divide by 3,600 to convert it to seconds. The equivalent is you divide by 3.6. Okay. One other thing, the context of this question sometimes confuses people. Okay, so this car is coming out of a corner and onto the straightaway. Okay, so we're talking about the car is right here, and at this point, it is moving at 140 kilometers per hour. Then it accelerates. Okay, so in other words, the 140 kilometers per hour is VI. Right. Okay.